Hello, let's try to solve another question from exponential equation. The question says if a squared plus b squared plus c squared is equal to ab plus bc plus ca, so that x to the power a divided by x to the power b whole power a minus b times x to the power b divided by x to the power c whole power b minus c times x to the power c divided by x to the power a whole power c minus a should equal to 1. So what we have to show is that these three expression they multiplies, or the product of these three expressions should equal to 1. So let us at first take the given information. So this is our given information, and we can modify this given information by bringing these three expression on the right hand side to the left hand side and just changing its sign. So we can write a squared plus b squared plus c squared minus ab minus bc minus ca equals 0 from the given information. We've just slightly modified the given information. Now let us jump right into the question. So this is our question, and when we look at this first expression, the first fraction, what we can write according to the rule of indices is that since these bases are same on both numerator and denominator, we can just subtract the power from the power of numerator to the power of denominator. So we can write x to the power a minus b instead of x to the power a divided by x to the power b, and I'll write the power which is outside the bracket as it is. I'll do the same for this remaining two expression. So here we are. After changing these three expression, I hope you understood the concept of the rule of indices which I've applied right now, that if the bases are same on numerator and denominator, then we have to subtract the power from the power of numerator to the power of denominator. So it gives us x to the power m minus n, where m is the power of numerator and n is the power of denominator. Once again, now let us look at the first expression here. Here the base is x and the power of x is a minus b, and there is our bracket, and the whole power we've got here is a minus b. So according to law of indices, here we can directly multiply the power here this the power inside the parenthesis and outside the parenthesis just multiplies. We can do same for this remaining expression. Now once again, what we can do here is since the same power has been multiplied twice, we can just write x to the power a minus b whole squared, and for another x we can do same. Since b minus c has been multiplied two times, we can write it as the whole square of b minus c, and similarly for third x we can do the same, c minus a whole squared. Once again, here we can expand the formula for a minus b whole squared, which is a squared minus 2ab plus b squared. Similarly, we can do it for this power of second and third expression. This is it. Now once again, here since the same basis has been multiplied, we can just write it in form of single base and add all the power of its base. So on adding, what we get is, we get a squared minus 2ab plus b squared, which is the power of first expression of x, plus b squared minus 2bc plus c squared, this is the power for second x, and c squared minus 2ca plus a squared, it's the power of third x. When we observe clearly, we can see a has been repeated two times. Similarly, b has been repeated two times, and also c has been repeated two times. So we can write it as 2a squared plus 2b squared plus 2c squared minus, and I'll write the remaining part as it is, minus 2ab minus 2bc and negative 2ca. Finally, here we see a 2 is everywhere in the power, so let us take 2 common from every expression of the power. On doing this, we get the expression in this form. Now, this part over here, the power a squared plus b squared plus c squared minus ab minus bc minus ca, we can just compare it with this given information over here, which is equal to 0. So in place of this red highlighted part, we can write 0, which gives us with x to the power 2 times 0, which is x to the power 0, and it is equal to 1. So yes, we proved what the question wants us to prove. So yes, I hope you got the concept, and thanks for watching.